Hello Math 2 Plus, welcome to our first video of the year. Ben Martinez asking for a joke, so I'll start off like this. So the other day I was talking to Ben, and then all of a sudden I tell him, you know, Ben, you remind me of like a square root of 2. And he asked me, why do you say that, Chan? And I said, well, it's because you're irrational. Ooh. Yeah, anyways, so let's go ahead and get started. So what I'm using here is something that you'll see me using pretty much all the time throughout the year, particularly when we graph. So this is Desmos. If you haven't used it with me last year, you're probably going to use it this year. You type in desmos.com/ you don't even need the calculator part, just desmos.com. And what I did here is I wrote a radical equation, right? And I put all the little transformation things here so that we have them. I just label them a little differently. I put a here, b, and then k over here. So it's a square root of x, but I have this a on the outside, this b inside the square root, and then a k right here. Okay. We haven't talked about any other types of indices other than 2, so like square roots. So we haven't talked about cube roots yet, but hopefully we'll move into those next week or next class. All right. So this is our most basic one. And what this is we've got a at 1, so this is a 1 right here, which means nothing's really happening if it's a 1, okay, or different, okay. Then we've got b, which is 0, which means this is x plus 0, which is just x. And then we've got k is 0, which means it's plus 0. So all this is f of x equals the square root of x. All right, so you can always play around with these things to see the slider tools. So watch as I increase a, it just makes it stretch out upwards. That's the vertical stretch. And then from here we're starting to compress it, and now it's flipped over to the other side. So once it's negative, then it's a flip over over the horizontal axis, essentially, okay, over the x-axis. Alright, so let's set this thing back to 1. Alright, so let's check out b. So as b becomes positive, we move to the left, and it's kind of come off our screen here. So b starts to move left when it's a positive number, and when it becomes a negative number, right, where it's like x minus something, then it starts to move to the right, which is what you see right there. Okay, so that's the other translation. And then finally we've got k. K is the one, oops, let me set this back to 0. K is the one that tells it whether or not to go up or down, so we'll see that here. If you make k go up, it'll go up, as in like a positive number. As it becomes a negative number, it'll start to go down. Alright, so what we're going to do here is I'm going to give you the secret code word that you need to write on your homework, that I'm just going to check real quickly on your homework so I know you looked at it. Okay, so the secret code word is bananas. B-A-N-A-N-A-S. B-A-N-A-N-A-N-A-N-A-S. I think that's too many N's. So you spell it correctly. I am having trouble spelling it. Alright, so here we go. We've got this one. Now that's our A. So we know that our A is negative 2. Then we've got this part. Our B is negative 3. And then we've got this part. Our K is negative 5. Alright, one of the things that I talked about in class, at least for the second class we had, is does it matter what order you do the transformations in? Yes. Okay, so one of the things you don't want to do is to do this first, where you say, I'm going to move it down 5, and then later flip it, because you'll end up in a very far away place from where you're supposed to be. Okay, so typically we say, read it from left to right, so I'm going to say flip, right? Flip over x. And then the next thing will be flip over x-axis. The next thing will be stretch by 2. Stretch by 2. And then the next thing will be left by 3, right? Because if it's a plus 3, then it means to the left 3. And you can see that when you play with the Desmos stuff. Essentially what it is what inside there would make it 0. So negative 3 would make it 0, right? Anything past negative 3, like negative 4, would be imaginary, so it wouldn't fit on our real real graph, okay, or real Cartesian coordinate if you want to say it that way. Okay, so left by 3, and then down by 5. Okay, and that's the k. So we're going to follow these things and just check to make sure it works. Flip over the x-axis. So the first thing I'm going to do is I'm going to take this and I make this a -1. Right? So we flipped it first. Right? Now the next thing you're going to do is you are going to stretch by 2, and you're going to see that over here. I'm going to take this, do it by 2. Right? Now when you guys have to hand graph them on your homework today, you're going to actually have to write the translations for some of them. Some of them you'll have to actually either plug in, or you can choose to make the original and then just translate the points over. By translate the points over, I mean like if you have 1, 1, right, and you did this flip thing, well, it became 1, -1. And if I said stretch by 2, instead of 1, -1, it's 1, -2, which is over here. So you can do that as well. You just need at least like 3 points or something. Okay. Just to help out, I'm gonna do that by doing these points as well. I'll do 1 point, so 1, -2. That's the point we have right now. That's because it's flipped over, and we multiply by 2 to stretch it. Now let's go ahead and continue with the translations. I've got left by 3, so if I go left by 3, that changes this point over 3 to the left, so it becomes from 1, okay, 1, then it becomes 0, I've moved 1, -1, I've moved 2, -2, I've moved a total of 3, so 1, 2, 3, and then my b was supposed to be +3. Okay, and notice that that point is exactly there. And the last translation we have here is -5. So k is -5. Okay, and let's check that. If I need to drop it down by 5 from that point, it should be -7. Let's check to see that that's on there. And yeah, it is. Okay, so you can see here from this graph that following the translations, you could do that with all the points. Just do that to each one of the points that you know. For example, 1, 1, 4, 2, 9, 3, and you just shift based on what the translations say, and then you can graph it. Okay, or you could do the old-fashioned way. I'll talk about that more in class next time. Alright, the last thing I need to talk about here is the domain and range. For those of you guys that had me last year, you guys remember domain is based on the x. Okay, domain is based on the x, or domain x, and the range is based on the y. It's the range. Alright, so I'm going to write it in this type of notation. So we're trying to write what x can be. So when we look at Desmos, we're looking at what things the x can be in this case. Let's zoom out a little bit. Right, so all of our x's are from here on. There's nothing to the left of it because we can't plug in -4 or -5, etc. Those don't work in our real number line or a real system here. Okay, so we look at the x's, and it can go from -3, and it can continue on and on and on and on and on. So we know that x, or all the values that are possible for x, every single thing that you can plug in, is x has to be greater than. And do you think it can be equal to? Do you think it'll be equal to -3? Let's check -3. If I plugged in -3, I'd get -3 plus 3, that's 0. The square root of 0 is 0. Right? 0 times -2 is 0. -5, it's just -5. So it can be equal to 3. So it's x is greater than or equal to -3. That's our domain. Right? And for the range, we're looking at all the possible values of y. Well, all the possible values of y are from -5 and beyond. -5, -6, here's -7, it's using -8 somewhere over here, using -9 somewhere over there. Now, if I said, will there be a point where there's, something comma -1000? From here, some people might say, no, man, it's moving too slow. But considering the fact that this goes infinitely long, like forever and ever, at some point it will reach it. Okay, in other words, at some point, maybe when you plug in like a billion, quadrillion, it will be that you can get a y value, or f of x, of a really large number. So all of your y's that are possible are from here on forever. Okay, even though you can't see it, it continues on and on going down. See how it's still going down? And if I just zoomed out forever, it would still go down. Okay. Alright, so let's go ahead and write our range. We know that y is less than, and does it ever equal, what was that point? Does it ever equal -5? Yes, it absolutely does. That point is -2, comma, -5. Oops, -3, comma, -5. Okay, that's that point, and it does equal -5 at that point. So it's less than or equal to -5. So that's our domain and range. And on your homework, it'll ask you a couple things about domain and range, how to write something like this, where it tells you, and then it'll tell you to graph a few of these things, and it'll tell you to do something like, well, if you're just different applications of that problem. Alright, so remember the secret word is what I said earlier. I'll see you guys in class.